An angle with its vertex at the origin and its initial side along the positive x-axis is said to be in standard position. The ray fixed along the positive x-axis is called the initial ray. The ray that is rotated about the center is called the terminal or terminating side of the angle. If the terminal side rotates counterclockwise, so this way, the measure of the angle formed is positive. If the terminal side rotates clockwise, so this way, the measure of the angle formed is negative. So let's talk about what all those things mean, starting with the first one. So an angle with its vertex. So by the way, trigonometry is the study of angles formed from right triangles and what kind of functions we can generate from that. So our study today is just going to start with some basic vocabulary about angles. An angle with its vertex at the origin, so that would mean a vertex right here where these two axes intersect, and its initial side along the positive x-axis. So if you think about an angle, I'm just going to draw an angle over here. This is the vertex. These two rays create this angle between them. They also create another angle outside them right here. So in this first definition for standard position, one of those rays is going to be along the positive x-axis. So that's this way. And we're going to call this one the initial ray, where the angle begins. Now let's say my second ray, I'm going to draw a second ray. And let's say it started also on the positive x-axis, but then rotated this way and ends here, or terminates right there. Okay, that's the terminal ray or side. And then this angle created, we're going to call that, the symbol is a Greek symbol for theta. We use that for denoting an angle measure, and it's said theta. So that's the basic pieces. If you have an angle that rotates counterclockwise, and so let's say I have this angle right here, this right angle. I had mentioned up here that the two rays create actually two different angles, this one and then this one outside it. So I'm going to need to show you here with an arrow if this angle I just created rotated counterclockwise or clockwise. And so if I draw this, that means that this terminal side rotated counterclockwise to create this angle. And that angle is theta, and it measures 90 degrees. But let's say I had that initial ray, and the terminal ray rotated 90 degrees again, but it rotated clockwise and ended here, right? So I had the ray, and it rotated down this way. Then it still went 90 degrees, but we're going to call that the negative direction. So both still measure 90. One went positive 90 direction, one went negative 90 direction. Another kind of angle we'll talk about is the reference angle. And it is the angle made by the terminating side and the x-axis and is always acute. So let's say I have this angle here. Now, here's my initial ray. Here's my terminating ray. This angle is 150, let's say. But the reference angle is formed by the terminating side and the x-axis. So that is this angle right here. And that is 30 degrees. And that is my reference angle. the angle made by the terminating side and the x-axis. So here's my terminating side. Here's my x-axis. So that angle is 30. If I had an angle that was larger, so here's my initial ray. Let's say my terminating ray went all the way around to here. Then here's my terminating ray. Here's the x-axis. Now this is the, let's say that's 30. That's my reference angle. And you see how that is acute. And then this is my actual theta. Let's say that's about 330. It's positive because it rotated this way. So this is the angle made with the terminal ray and the x-axis. If the terminal ray of an angle in standard position lies along an axis, any of the axes, then that angle is called a quartile angle. So there are 4 different quarters, so there's 4 different ways this angle could go. The first one, so they all are going to have the initial ray here. So let's say in the first one, the terminal ray rotated to this axis right here. Right, so it just has to, the terminal ray lies along an axis. So rotates here, lying along the positive y-axis. This is a quartile angle and its measure is 90 degrees. Let's say though the terminal ray goes past the 90 and down to this axis, and now it's going out this way. Also, we're going to call that a quartile angle. The terminal ray is along an axis. It's the negative x-axis, and that measure is 180. Let's say now that our angle, our terminal ray is in the negative y-axis. That measure is 270 degrees. And then if the terminal ray goes all the way around and ends up where it started from, so I'm going to put a second arrowhead here to show that the terminal ray is on top of the initial ray, then that is 360 degrees, also a quartile angle because the terminal ray lies along the positive x-axis. So this is something I already mentioned. The Greek letter theta, looks like this, is used to represent the measure of an angle. 2 angles in standard position are called coterminal angles if they have the same terminal ray. So here's what I mean by that. So I've got my initial ray here, and I'm going to draw this terminal ray. So there's 2 ways that this could be the terminal ray for an angle. One is if I started at the initial and rotated up counterclockwise, and that would be a positive 30 degrees. The second way this could be my terminal is if I started at the initial and rotated down clockwise and ended at the terminal. So now that I've rotated clockwise, it's going to be a negative measure, and it's going to be 330 degrees. So 330 and 30, that adds up to 360 for the entire circle. Another example over here, let's say this is my initial ray, and this is my terminal ray. There's 2 angles made that share that terminal ray. One where you rotate counterclockwise, that's going to be a positive 180. And one where you start at the initial, rotate clockwise to the terminal ray, and that would be a negative 180. Now, for the rest of this lesson, we're going to talk about converting degrees into radians and vice versa. But for a second, I just want to talk about what that even means. All right, on this next section, we're going to change degrees to radians and vice versa. But first, I want to take a second and just explain what degrees and radians are. So imagine that I have this coordinate plane, and I have an initial ray and a terminal ray. Okay, and that creates some angle theta that's measured in degrees. Well, imagine for a second if this distance was 1 and I had this circle here that goes all the way around. The angle measure is in degrees, and if I went all the way around the circle till the beginning again, we know that that is 360 degrees. And that's the angle measure of one rotation around. But I also know that this circle has a circumference, and that the formula for circumference is 2 pi r. Well, let's just standardize this to a radius of 1, and that becomes just 2 pi. So the angle measure for the circle is 360 degrees. The distance traveled around the circumference of the circle is 2 pi, right? This one is degrees, and this one, we're going to call that unit radians. And the portion of the circumference that corresponds to a given angle is the section between the ends of the rays right here. So if I have this angle, this is in degrees, this corresponding section is in radians, and they are in proportion to each other. So we can convert between one and the other. If I know this in degrees, I can figure out this radians. Vice versa, if I knew this in radians, I could figure out the degree measure of this angle. And if you just set up a proportion of these two values, 360 compared to 2 pi, simplify that fraction by dividing 2 out of each of those, and we have 180 over pi. So for every 1 pi radian, you go around 180 degrees. And we can use this proportion to convert between the two units of measure. So that's what we're going to do over here. To change degrees into radians, you're going to be starting with something that's in degrees. You're going to take that value, whatever that is, and multiply by pi over 180, and that will give you a radians measure. You'll have pi in your answer, and it'll be radians. If you were starting with radians and wanted to go to degrees, you take whatever your radians measure is, and this time you would multiply by 180 over pi, and that would give you your degrees. So in this first example, we're going to change 65 degrees to radians. So we start with our degree measure times pi over 180. And when we write our radian answers, we are going to write them in reduced fraction form. So I'm going to simplify 65 over 180 by dividing 5 out of the numbers, and that will give me 13 pi over 36 radians. So that would be the portion of the circumference of the circle that corresponds to a 65-degree angle. And then in the second example, we're starting in radians. That's why there's a pi there. So we're going to do a radian times 180 over pi. And one clue that the pi needs to be on the bottom is you're trying to cancel them out. So if you have a pi on top and a pi on bottom, they cancel. Now multiply across the top and bottom. That leaves me 180 over 12. 12 goes into both of those, so I'm going to divide that out, and it gives me 15 degrees. So down here, I'm running out of time on my video recorder, so I'm not going to work through these. They work like these up here do, but go ahead and check the PDF in your Google Classroom. Practice these. Check your PDF in the Google Classroom for your answers. Notice it does say to draw. The only thing different about these and up here is you have to draw the degrees for the angles. Remember, if it's a negative angle, you're going to start at your initial terminal or your initial ray and rotate clockwise down.